Hello, math students. Today we're doing the second lesson in our 2D geometry unit. If you remember yesterday, whoa, we talked about the unit as a whole. So the first lesson we looked at was just basic area of parallelograms. Done. Today we're moving on to triangles. Now, we also talked yesterday briefly about what is a polygon. Polygon is all the shapes we're going to be looking at. Shapes that have straight sides, at least three sides. And today we're going to be doing that beloved three-sided shape known as the triangle. We're going to be working on finding the area of triangles. So, without further ado, a quick bit of notes slash lesson, and we'll do a few examples, and then you can hopefully use that to complete today's practice problems. All right, the area of a triangle. How do you find it? Very simply, the area of a triangle is, it's equal to 1/2 of the product. Product means multiply. And here's those words from yesterday, base and height. So the area of a triangle is equal to 1/2 of the product of the base and height. So if those words feel a bit confusing to you, let's put that into a formula. Sometimes that's easier to see. You can write this formula one of two ways. It's up to you, whichever you prefer to look at. But, all right, the product of the base and height means I'm multiplying the base and the height, but it's 1/2 of that. So how do you find half of something? Well, you have two options. Option one, base times height, and then you can just also multiply that by 1/2. So sometimes you'll see the formula for the area of a triangle written as base times height times 1/2. Alternatively, there's another way that you can write this formula, and it's up to you which way you want to express it. But the other way is area of a triangle is equal to base times height. And to find half of that, you could just divide that whole product by 2. So base times height times 1/2, or base times height, and then that product divided by 2. Both formulas will accomplish the same thing. It's up to you which one you want to use. But similar to yesterday, we also need to talk about what is the base and what is the height within a triangle. So I've got two triangles here that we're going to look at to determine what the base and the height is. And the first triangle is this pinkish one, and the other is this greenish one. This is a right triangle. We know that because it's got a right angle formed right there. But anyways, I've written this out for you, so let me just move this out of the way. The height of a triangle is, remember yesterday, straight. It's the straight distance. And that straight distance needs to go from whatever side we're calling the base to the furthest point across from the base. So let me explain that using a little bit of drawing on here. If we wanted to call in this triangle, if we want to call this side the base, then the height has to be a straight distance that goes from the base to the furthest point from the base, which would be this point up here, meaning the height would have to be a straight line that goes right down the middle. This would be the height. The height would not be either of these slanted sides. I said this in the Google Meet yesterday to some of the people that were there. If I asked you to find the height of the wall in your room, or wherever you are right now, you would not measure that height slanted. You would measure it straight up and down. So the height of a triangle needs to be going straight up and down from the base to the tallest point across from it. Let's erase what I just did. What if we said the base was going to be this side? Well, then the height would need to go to the furthest point across from the base, which is over here now. So if we're going to call that side the base, then the height is going to be going down the middle here. Point being, when you are looking at a triangle, and let's say you have all the sides give you measures. Not all of that information is going to be used in the problem. You have to determine, where is the height? Is the height going this way? Is it going straight up and down? And then that height will tell you which side can be used as the base. In a right triangle, it's actually pretty nice because you have a straight up and down side and you have a side that's going this way. So if the sides are all given to you, this would be your height and this would be your base, or vice versa. You're multiplying them together, so it doesn't truly matter which one you call base and height, but these would be the two useful sides. Alternatively, just for the sake of showing you, um, let's say that you had this side given to you. Well, where's the height then? The height goes from the furthest point across right down the middle, straight line. That's a straight line going from the base to the furthest point from it. So pay attention to what the base and the height is. These problems aren't super hard. It's the hardest part can be determining what the base and the height are. So here's our first example. There's that green triangle again, giving it some measures very simply. Area is equal to base times height. Cut it in half. I'm going to do divided by 2 for my formula. Okay, the base is 8. The height is 5. 8 times 5 is 40. Divided by 2 is 20. So for this green triangle, it takes up 20 square inches of space. That's what the area is. So there's your first example. Our second example, we will use this beautiful ombre, I think that's the word for it, pink triangle. And in this, whoa, what do we have here? We got this weird extra dotted line thing. Well, why is that there? Because it's showing the straight distance from the base to the furthest point across from the base, which is, in this drawing, this 9-foot measure. So that has to be the height. That has to be, it's straight. I could have drawn it right down the middle. I just drew it on the side. It's the same thing. It's the distance from the top to the bottom. So area equals, I'll use the other formula this time, base times height times 1/2. So the base is 12, the height is 9, and then cut that in half. So that would be 108. Cutting that in half would be 54. So the area of this nice pretty triangle is 54 square feet. It takes up that much space. That's what area refers to. Cool. Lastly, let's do one more example. I don't know if you've ever heard of the Bermuda Triangle, but it's this place where it's been rumored that that's where a lot of ships have been lost. It's like this weird place in the ocean, and people have triangulated the area of where that Bermuda Triangle is, and the triangle is formed from Bermuda to San Juan to Miami, and we can find what's the area that this little weird space in the ocean that swallows ships up. How much space is that? Well, the area of the Bermuda Triangle is equal to the base of the triangle that was formed multiplied by the height of the triangle that was formed and then cut in half. So the base is 1,000 miles. It is approximately 1,000 miles from Miami to San Juan. That's where that distance came from. And then from Bermuda straight down to the base of the triangle that was formed is about a 900-mile distance. So 1,000 times 900, and then you just cut it in half. I'm sure many of you realize this is going to be a big number, but 1,000 times 900 is 900,000. Cut it in half is 450,000 square miles of space in which your ship can get lost if you're sailing, apparently. Never been there, but that's how it works. Anyways, that's area of triangles. The lesson's pretty simple for today. Just take your time. Go back through this video as needed. Use the examples I did. And if you have questions, reach out or feel free to join the Google Meet that's happening. Otherwise, Sayonara, enjoy your day. It's supposed to be sunny, so get outside at some point, ride your bike, go for a walk, stare at the clouds, find a cool shape, maybe a triangle. See ya.